Okay guys, we're solving with logs today, section 7.4. So an easy problem we have, okay, is something we've been doing pretty much already. We have log base 9 of x equals 3 halves. Okay, we would turn this around. At least you don't have to, this is how I would do it. Turn it around, 3 halves equals log base 9 of x. Okay, and that helps to remind me 3 halves is the power of 9 that equals x. Okay, and I can just type that into the calculator, 9 to the 3 halves power, and I get 27. You try this one here. Log base 16 of x equals 5 halves. Go ahead and push pause and work on that for a minute. Alright, welcome back. Let's see how you did. Okay, we're going to turn it around. 5 halves equals log base 16 of x. So this is going to tell me put the 5 halves on top of 16. 16 to the 5 halves equals x, and we'll get 1024. Did you get that? Okay, take a look and compare mine with yours. Now x won't always show up right here in our problems for today in the book. Okay, it might end up being up here or down here. Okay, we want to rewrite these. This is not a new type of problem that's going to stump you. Remember, we've done this before. You want to rewrite these as a common base. Okay, so what does that mean? I want to rewrite everything as a 2. Okay, this is 2 to the negative first to the x, and 4 can be rewritten as 2 squared. When I have exponent, parenthesis exponent over here, we get to multiply. This is 2 to the negative x equals 2 squared. Okay, the only time this is going to be true is if negative x equals 2, or if positive x equals negative 2. Okay, you've done those before, so don't get tripped up when you see them. There are going to be quite a few that look like this, but then there are going to be a few where x isn't always right here. It's going to be somewhere else in the problem. We need to use our common base to solve those. Alright. Then we have our medium type of problem, okay, where that's going to involve the property of equality for log functions, okay, which pretty much says if I have log base b of something equals log base b of something else, then those two things, x and y, have to be equal to each other. That's the only way this will be equal. This is the same, log base b and log base b. The only thing that's different is x and y. So for this to be equal to that, the x has to be the same thing as y. Okay, so it starts off pretty easy. Alright, so here we have log base 3 of x squared minus 15 equals log base 3 of 2x. So the only way this is true is if this part equals this part. So x squared minus 15 equals 2x. We got that from our property that we just had. Okay, now this is a little different. This goes back to our x squared, our quadratic strategies, our x squareds. Okay, we want to get everything on the same side whenever we're using x squareds. So put everything on the same side. So I had to subtract the 2x over. X squared minus 2x minus 15 equals 0. Okay, then we can factor what multiplies to negative 15 and adds to negative 2. Negative 3, positive, or my fault, negative 5, positive 3. Okay, so if it doesn't factor out nicely, what could you do? Quadratic formula. But I'm pretty sure they all factor out nicely today. And then we do opposites. So it should be 5 and negative 3. So that's not bad. That's not bad. But now, here's the extra part. It's also not very difficult. It's just an extra step, a little tedious. You have to go back and test them. Test each one to be sure they work. Because this part of our log needs to be positive, needs to be greater than 0. So I have to put this in. Does 5 give me a true statement and have them both be positive? 5 squared is 25, minus 15 is 10. 2 times 5 is 10. They're both log base 3 of 10, and 10 is positive, so that's good. Over here on the other side, testing out negative 3. Negative 3 squared, be smarter than the calculator. Negative 3 times negative 3 is 9. If you don't type that in carefully into your calculator, you're going to get negative 9. Okay, negative 3 squared is positive 9. Minus 15, negative 6. 2 times negative 3 over here, negative 6. They equal, so we're thinking it's good, but domain error, we can't have negatives. They have to be, we can't have 0 either there really. We need to be greater than 0. They need to be positive numbers in there. So we're not going to use that one, and we're just going to take x equals 5. We're going to cross out the -3 one. Okay, you go ahead and give that one a try. Log base 2 of x squared minus 4 and log base 2 of 3x. Go ahead and hit pause and try that one. Okay, so we should have x squared minus 4 equals 3x. We'll subtract that 3x over. We'll factor what multiplies to -4 and adds to -3. How about x minus 4 and an x plus 1? -4 times 1 is -4. -4 plus 1 is -3. So my answers here are going to be positive 4 or -1. Go ahead and test those out. 4 squared minus 4 is going to be 16 minus 4 is 12. And over there, 3 times 4 is 12. Positive, and they match. Good. Try -1. -1 squared is 1 minus 4 is -3. And then 3 times -1 is also -3. They match, but they're negative. So we're going to cross those out, and we only want x equals 4, not -1. Okay? A lot of testing out. Alright, this is the day 2 portion. This is the day 2 portion of 7.4. Same stuff, but with inequalities. Same stuff, but with inequalities. Okay? So our first type of problem, they give us some rules to follow. Okay? So if b is greater than 1 and x is greater than 0, and I have a log base b of x greater than y, then I can just do this shortcut. X is greater than b to the y. Okay? Same thing here, but if it's a less than, then I'm going to have x is less than b to the y. But also, remember that this x needs to be greater than 0, so we have to tack that on there. That's why they have a greater than 0 there. Okay, so I'll show you both ways here, using the shortcut and using the long cut if you forget the shortcut. So here we have a log base 3 of x greater than. That's going to match our top one. Okay, so let's do our shortcut here. X is greater than the base 3 to my y, 4, greater than 3 to the 4th. X is greater than 81. Pretty short and sweet. What if I forgot? Well, I'm going to try to do it how we did it with the equal signs. We're going to flip it around, and now when I flip this around, to flip it around correctly, I need to flip that with it to make sure that the little end is pointing at the 4. Okay, so 4 is the power of 3, so 3 to the 4th is less than x. So 4 is the power of 3 that gives me x, and then we're going to keep this sign the same. We'll still end up with 81 is less than x, or if you spun it back around, x is greater than 81, which matches this one, but this one was a lot quicker and a lot less thinking if you can do the thinking up front and remember the shortcut. Here we have a less than, so follow our less than shortcut. 0 is less than x is less than base 3 to the 4th. Less than 81. Shortcut, super easy. Long cut, I forgot it. I forgot how to do the shortcut. So my first step is I'm going to flip it around, and when I flip it around, I need to flip the inequality with it so that the big side here is still pointing at the 4. Okay, now this reminds me, 4 is the power of 3 that gives me x. So 3 to the 4th and x, and I keep this the same. Alright, 81 is greater than x, or x is less than 81. Now the thing about this is there's a lot of numbers that are less than 81. 80, 79, 78, 3, 2, 1, 0, all the negatives. Alright, we got to remember that if x is less than something, we have to make sure that we stay, to follow our rules here, we have to be greater than 0. Same thing. Okay, that's only with less thans. With greater thans, you don't have to worry about it. With less than, x is less than something, we got to put on that 0 on the backside for this type of problem. Last type of problem. Okay, we got logs on both sides. Log base 4 of x plus 3 is greater than log base 4 of 2x plus 1. So the log 4 and the log 4 are the same. The only way that this side is greater than this side is if this part is greater than this part. So x plus 3 needs to be greater than 2x plus 1. Alright, so there's no x squareds going on, so we don't need to do our quadratic tricks. So we're just going to get x by itself. 3 is greater than x plus 1. Subtract the 1. 2 is greater than x, or x is less than 2. Okay? So x is less than 2. We got that part down. I also have a sneaking suspicion that, hey, wasn't the last thing we did here with a less than, didn't have to have another rule. It's got to be greater than 0. Alright, but what has to be greater than 0? This part. In these types of problems, the x is just by itself. It's just x. There's no x plus 3. There's no 2x plus 1 to change it. It's just x, so this is just straight up x has to be greater than 0. Here there's other stuff going on to that x, so x itself doesn't necessarily have to be greater than 0. Just whatever the whole thing in here equals does. So I'm going to take this and put it over here, and this and put it over there. So x plus 3 has to be greater than 0. Which means that x is greater than negative 3. And over here, 2x plus 1 has to be greater than 0. Okay? Subtract the 1. 2x is greater than negative 1. Divide by 2, x is greater than negative 1/2. So now I have 3 inequalities. How do they all relate to each other? Okay? How do I tie all these in? With a number line and a graph. Okay, these are all less than or greater thans, so they're all open circles. So I'm just going to plot these points, and they don't have to be accurately spaced or anything really. 2, this one's negative 1/2, this one's negative 3. They should go in order, obviously, but you don't have to have like even tick marks throughout there. Okay? And then this is graph all 3 on a number line. Okay, x is greater than negative 3, so open circle, and we go greater than, that's to the right. X is less than 2, open circle, left, and this one's greater than 1/2. Okay? And now where do all 3 lines overlap? All 3 lines are right there, between negative 2, or my fault, negative 1/2 and 2. So our answer then, where all 3 lines overlap, so all 3 lines overlap, that means that all 3 of my inequalities are satisfied there. So we need to have negative 1/2 is less than x is less than 2. We just get to go right in order. Okay? Wasn't shaded here, it was here. There's where all 3 of them overlap, so that's my first number. Less than x, less than the last number, 2. Now you might get all of them going the same way. In which case, where are all 3 lines? Over here. So then you would just say x is greater than a number. Or if it went the other way and all 3 lines went to the left, x would be less than a number. You don't have to have betweens. You could get all to one side or all to the other side, and then you just have x is less than a number or x is greater than a number. Okay? So that's both days, day 1 and day 2. Both assignments here, we're going to start with page 480. Day 1 is 13, nope, my fault, 8 through 19. 8 through 19. And then day 2, with the inequalities, is 22 through 33. Alright? So go ahead and get started on that. Hopefully that helped. These have been pretty short lessons, so I've been trying to squeeze 2 days into one video, so it saves some time for me. So make sure we're paying attention at the beginning there if it's a day 1 or a day 2, if it's going to be a combo video with both. Alright, thanks a lot guys. Hopefully this helps you.